So we're creating this video to provide some information about some technicalities of the orthotics. Today we have technology that allows to use CAD-CAM technology in order to manufacture, design or products or orthotics. The advantage of the utilization of CAD-CAM first is the density of the material. This is industrial PMMA that is compressed under tons of pressure and in perfect conditions to be able to make big discs and be able to mill these appliances. So the density is longer, doesn't stain, they're really more compact, but that doesn't make it stronger. Remember that the more stronger a product is, less flexibility it has, and then it will become eventually more fragile. So the two products that we offering is a PMMA material, polymethyl methacrylate, an industrial acrylic that is dense for a puck, for a build disc that we mill this. And we have acetyl resin. Acetyl resin is a combination of PMMA with some particles that like nylon, so create more flexibility. It's based in the concept of a glutamate material, and that's the other option that we have. Important to understand about the two different products is the properties of each one. When we talk about PMMA material, we have the alternative to reline it and internally or externally if you want, for feed or for any other reason, or the occlusal surface you want to resurface, to the PMMA material you can add. The other material that is a nylon has the limitation that cannot be relined. It's not compatible with acrylic, so they don't mix together. The flexibility of the other material will make that the acrylic will flick off and it's not gonna work. So it's important to understand the limitations of the appliances so your prescription is gonna have a more precise idea. One of the biggest issues that we have with the CAD-CAM orthotics, a difference that they manually done, that is the combination of two materials. When we make orthotics by hand, we use a material that is similar to nylon, it is soaked down, and on top of that we put acrylic. So if the orthotic goes to the floor or everything, the nylon is more resilient than the pure acrylic. So these materials, that these CAD-CAM orthotics, are fully dense in the two options of material that we have, but they cannot be mixed together, so impossible to have the properties of both. So the main property of the PMMA, the acrylic one, is that you can reline it. For that one, you need to count that still we need to have some thickness, because the manufacturer, they say that we can have 80 megapascals of strength if we have 2 millimeters. As many courses we take, the indications is that we should take the byte registrations in the minimal spot about 2 millimeters. Now, it's important that we understand these graphics that I'm gonna show here, because this is what is happening most of the time. For instance, we have an upper model here, and this is a lower model. Technically, this is the space that we need to go over the lower model, and this minimal thickness need to be, if you want to guarantee the strength that the manufacturer said, that about 80 megapascals of strength need to be 2 millimeters. But if the byte that you take create a cross byte, for instance, we're gonna have areas that we cannot have those 2 millimeters. Those points, technically, it will be fracture points eventually. Why? Because if in 2 millimeters we have 80 megapascals, in areas that we have less, so we're gonna have half of the strength. So these areas of cross byte, they're gonna be really fragile and with the tendency to break. This is an anterior view, so this is an upper tooth, this is a lower tooth. And in this particular case, for instance, when we're gonna make the lip bumper to create the ramp, we also recommend, if you want to keep the integrity of the lip bumper, that at least in the anterior area, we can have 1 millimeter. That's a minimum. But it's gonna be cases with class 3 patients, and then eventually those cases cannot even have the lip bumper, can have a ramp for behind, but it's impossible, it's not a space to that. So in order to try to gain a little more space, we start working in products that it was the nylon. And the nylon offers a little more flexibility. It's a material that technically it can squeeze. So this is a material I'm gonna make some showing so you can see how strong the materials can be. First of all, this is just a regular acrylic. And part of what I want to show is that you can see that when the orthotics are in the mouth, they cannot break. You don't gonna have this strength of the occlusion, and this is a regular acrylic one. You don't gonna break the orthotic since if the orthotic is installed in the patient's mouth. And sometimes patients come with the excuse that they were biting just a cookie and the orthotic break. But if you see, the orthotics cannot break into the mouth. But if the orthotic is out, and this one I just broke it right before, yes, it's gonna have more fragility because the walls is gonna be thinner. Also, something that we need to consider is that we have a thickness that go around the wall, but in the middle fossa here, technically is less thickness because we're not making flat planes. So we're gonna have anatomy so that make that's fragile. So that's the second point. If a patient has an orthotic in the mouth, and then let's think that this is a whole piece, and the patient removes only one side because the orthotic, let's say that is too tight, that is going to create a fulcrum into the orthotic that is going to have the tendency to try to break it into the half of the occlusal table. Why? Because to the time that you deflect this surface, not in this one because this is quite thick and we have big space, but when the patient try to take it higher to one side, all this torque is expanding this internal wall in a PMMA material, for instance, that is not flexible at all, and that would create some cracks that happen here, and mostly in the second molar, that line can delaminate the entire two molars. Unfortunately, this is all patient handling. Also, these orthotics are really fragile when out of the mouth and they can break in pieces. Again, this is already breakage, so let me just show in another one. So this is a regular acrylic. Pretty much I think is the same case, and again, this doesn't have flexibility. If I have into the model, it's not gonna break. But if I put it into my hand, I'm gonna break it. It's gonna break in the area of less resistance because also we have a path of insertion. Now, these orthotics that is in acrylic, yeah, they can chip in pieces. We have this nylon option that doesn't bond to anything, but we have the alternative that this material flex. Doesn't mean that it's not gonna break, but we can abuse it a little more. You can see I'm squeezing it, and the material is not breaking. Technically, it can unadapt, but no breakage. Has to match it really hard to break it, but they are still trying to be together. So it's important that you take these considerations. The decision to you to choose between a PMMA material and the different to use with a nylon material can be if you have to rely on or not, but also depends on the quality of your impressions. If you have teeth that they're really short, with lack of retention, your impressions need to be perfect because the little only retention that we're gonna have is gonna be the high contours. And we have sometimes occlusal anatomy that they're really poor. The other problem that we have is that we have, in many cases, a lot of tags because many doctors, they don't use a wash material, so they use the heavy body, and then we have tags. Those tags are always in the area that we need retention. So all those cases, if your impression is not good, and eventually you will need to have an internal reline, nylon is not gonna be your option. So my advice is we need to have perfect impressions, like for crown and bridge. We need to have all these internal embrasures properly with no distortions or tags, need to be totally clean. Also remember that we have cases that we have divergency into the walls of the case that we will need to block it more aggressively to allow the path of insertion. So remember, technology gives us products. We need to be able to prescribe what we need. Here is the two definitions between a nylon material that technically can be hammered and still trying to keep the integrity versus a material that is PMMA that is so hard, amazing, but it can break in pieces just because it doesn't have that flexibility. So every time that a patient comes with an orthotic that is broken and it's a PMMA, for sure that orthotic wasn't in the mouth. That orthotic falls into the floor and it breaks because PMMA, because it's so dense, it breaks, or they put it in the pocket, or technically is the way that they remove it from the mouth that again create an internal expansion into the surface. And since we have a central group that is most of the time thinner, and most likely in cases that when we have these cross bites, that this create areas with less space, it will create a more easy way to break. So if we get all these considerations, we can for sure manufacture products that fit what we guarantee, that is a perfect handling in the occlusion, the bites, the mounting, a beautiful appliance that can be presented to the patient, but also is a key, the prescription of the material that we have to use and the proper instructions for the patient, because it's a high risk that the patient can break the orthotic in their own house. Thank you so much. I hope this is helpful.